वालेकुम डियर स्टूडेंट्स। इन क्वेश्चंस के अलावा जो कि मैं वीडियोस बना के लगा रहा हूँ, अगर आपको कोई और भी किसी और एक्सरसाइज से कोई और चैप्टर से कोई क्वेश्चन आपने समझना है, पूछना है, तो आप मुझसे रब्ता कर सकते हैं और मैं कोशिश करूँगा कि प्रायोरिटी पे आपके जो बताए हुए क्वेश्चंस हैं वो उसकी वीडियो बना 1.2 and the question 1 is identify. We have given some matrices and we identify these matrices are unit matrix, row matrix, column matrix, null matrix, etc. And to start with question 1, we have A matrix, which is 0, 0, 0 and 0. And we know that when all the elements of a matrix is 0, then it is called a null matrix. And the next is B matrix, which is 2, 3, 4. Here we saw only one row is available, which is 2, 3, 4, and we tell it row matrix. And the next C, this matrix is 4, 0 and 6. In this matrix we saw only a column is available, so we tell it column matrix. And the next is D, which is 1, 0, 0, 1. Here only a diagonal elements available which are only 1. So these values which have diagonal only 1 is called identity matrix. Identity matrix. And next is E. In E, only 0 is the element of the matrix. Mean it is only 0 element and we called it null matrix. And the last is F, where the elements of the matrix are 5, 6 and 7. Here is only a column, so we tell it column matrix. Question 2 is, in question 2 we have some matrices and we identify which is square matrix, rectangle matrix, row matrix, column matrix, identity matrix and null matrix. So one by one we write and identify. 1 is equal to, first part is -8, 2, 7, 12, 0 and 4. The matrix, this is have 2 rows and 3 columns, and we know that from the definition, when the number of rows and number of columns are not equal, that matrix is called rectangle matrix. So it is a rectangle matrix. And the second part is 3, 0, 1. And the matrices which have only columns are called column matrices. And the third is 6 minus 4, 3 minus 4. And from the matrix's definition, when the number of rows and number of columns are equal, then they are called square matrix. So it is a square matrix. Square matrix. The fourth is 1, 0 and 1. The matrices whose diagonals are only 1 are called identity matrix. Identity matrix. And the fifth is 1, 2, 3, 4, 5, 6. Same here. When the number of rows and number of columns in a matrix are not equal, they are called rectangle matrix. So it is a rectangle matrix. Rectangle matrix. And sixth is 3, 10, minus 1. And when in a matrix is only a row, that is called row matrix. And next the seventh, 1, 0, 0. Here there is only one column, so we tell it column matrix. Eighth matrix is 1, 2, 3, minus 1, 2, 0 and 0, 0, 1. In this matrix, the number of rows and number of columns are same, that is 3, 3. It is called square matrix. And the last is 9th, 0, 0, 0, 0, 0 and 0. And we know that when all the elements of a matrix is 0, that is called null matrix. In question 3, some matrices are given and we identify them: the identity diagonal, scalar and unit identity matrix. So we write one by one and identify. The A matrix is equal to 4, 0, 0, 4. It is a diagonal, but there are a same number, but that is 4, 4. It is called a scalar matrix. Scalar matrix. And the B is 2, 0, 0 minus 1. Here also a diagonal matrix, क्योंकि diagonal elements are available in diagonal and it is called a diagonal matrix. Diagonal matrix. And the C is 1 0 0 1. This is also a diagonal matrix, but in the diagonal positions only 1 is available, so it is called a identity matrix. Identity matrix. And the next B is 3 0 0 and 0. Here is also the two different values, one is 3 and other is 0. It is a called diagonal matrix. And the last is E. This matrix is equal to 5 minus 3 0 0 1 plus 1. We first simplify the values. 5 minus 3 is equal to 2, 0 0 and 1 plus 1 is equal to 2. Two same values in the diagonal position, so we set it scalar matrix. Question 4. In question 4, find the negative of matrices. We have A, B, C, D, E matrices and we find the negative of these matrices. We take first A is equal to 1 0 minus 1, and when we take negative matrix we write it minus A, and the elements of A matrix we change their signs. The new signs are minus 1, 0 and plus 1, and it is the negative of matrix A. And next is B matrix, which is 3 minus 1 2 and 1, and when we find the negative of B matrix we also write minus B, and the element of matrix B we change their signs, mean positive shifted into negative and negative into positive, which are minus 3 1 minus 2 and minus 1. It is the negative of minus 2. The next is C, 2 6 3 2, and minus C is equal to the elements of C is also change their signs, minus 2 minus 6 minus 3 and minus 2. And next is D, the elements are minus 3 2 minus 4 and 5, and minus D is equal to plus 3 plus 4 minus 2 and minus 4. And the last is E, in which the elements of matrix is equal to 1 minus 5, 2 and 3. And then minus C is equal to, change the signs of all the elements, minus 1, plus 5, minus 2 and minus 3. And it is the negative of minus C. Start question number 5, in which find the transpose of the matrices. In transpose, the number of column and number of rows are interchange each other, we get the transpose. So A matrix is equal to 0, 1, minus 2. And when we find the transpose of A, we write here in front, in the position power side, AT. A mean A transpose. Here is only a column matrix, but when we take it transpose, we change the column into row and row into column. So we write it 0, 1 and minus 2. It is a A transpose. The B is equal to, is a B column row matrix 5, 1 and minus 6. And B transpose is equal to, this row is changed into column 5, 1 and minus 6. The next is C, whose elements are 1, 2, 2, minus 1, 3, 0. And transpose of C is equal to, we change column into row and row into column, we get 1, 2, 2, minus 1, 3, 0. And it is the transpose of C. So the next is D. The matrix D is 2, 3, 0, 5. And D transpose is equal to 2, 3, 0 and 5. E part, the E matrix is equal to 2, 3, minus 4 and 5. E transpose is equal to 2, 3, minus 4 and 5. This is transpose of matrix C. And the last is F. And in the F, 1, 2, 3, 4. And when we get transpose of F, we change its row into column, we get 1, 2, 3 and 4. In question 5, we find the matrices, transpose of matrices. The question 6 is equal to, we have A matrix 1, 2, 0, 1 and B matrix, which is 1, 1, 2 and 0. And in question 6, there is two parts. The first is A transpose, A transpose is equal to A. And the other is second, B transpose, whole transpose is equal to B. So we take part 1, A transpose, whole transpose. The A matrix is equal to 1, 2, 0, 1. And we take its transpose, we get row into column and column into row. And again we take transpose of this matrix, we get same row into matrix and row into column and column into rows. 1, 0, 2, 1. And this is the A matrix. In the same way, we get B matrix, and in B matrix we take B transpose and then whole transpose, get the answer B matrix. Now the second part is B is equal to 1 1 2 0. We take its transpose, we get row into column and column into row. And again we take its transpose, we get 1 2 1 0, and this becomes the matrix P. So hence A transpose is equal to A, and B transpose whole transpose is equal to B.